Unfortunately, I have this class. Okay, teaching in the spring. I teach it several times, but the spring was good. See, the video is not good, I send the corresponding class for this. And you see at least something. Okay. So the thing I tried to explain was, the first thing you should do is multiplication by 2 times f of x. And what is the name of this transformation? It's vertical stretch. Factor 2. So point by point. 0, 0, no. 0, 0 stay the same. 0, 0 stay the same. Because you multiply 2 times 0 is 0, no? Remember, you multiply the y component. 0, 0. So x stays the same, is 0, and y is 0 times 2 is 0. However, this point at 4,2 now is 4,4. Because we multiply the y component gets 2 times 2. And 2 times 2 is 4. 4,4. 4,4. And this guy is 4,8. So minus 2,8, sorry. Minus 2,8 here. Minus 2,8. Okay, so my graph after the transformation looks like that. And makes sense que es vertical stretch because it's not only motion, so there are deformation for the shape of the graphic because you multiply by 2. And you multiply by 2 occur vertical stretch. And finally, negative 4. Negative 4 is any point you subtracting 4, and this is obviously the last is a vertical shift. Vertical shift. In what direction? Down or up?
Down 4.
Down, down, down. How many units? 4 units, right? So point by point, this point normally is 0, 0 would be now 0, negative 4. Because it's negative 4 subtracting in the y. This guy is negative 2,4. Because 8 minus 4 is 4. And this is 4. 4 minus 4 is 0. Is 4,0. And this is the last graphic of the last transformation. Now it's super clear now?
Yes. Yes.
Excellent. Okay. The last topic is a combination of the function. We are studying now, guys. Not only one. We have combination of the function. So combination of the functions. Of that functions. So we have 2 functions, 3 functions, and there are different ways to combination. The most popular combination is using arithmetic operation, addition, subtraction, multiplication, and division. Now, suppose the symbolic way you have 2 functions, f of x and g of x, and you can combine using plus, addition, sum. And the symbolic way to indicate this idea is possible doing it that way, parenthesis f plus g of x. Okay, symbolic, and this is the natural way. And subtraction, well, similar. F minus g is important specification who is the minuend and who the subtrahend. Not necessarily you can interchange, of course, no. Multiplication is f times g of x. And finally, division. This is symbolic. In the test, you can see this way or this way. So the first way is the explicit, and another is symbolic. The most important is the domain. The domain of this. So the domain of this 1, 2, 3, case addition, subtraction, and multiplication is domain of the first function intersection domain of the second function. Suppose that this is the domain of f, and this is the domain of g. This is f, this is g. However, the domain of the connection is this one, intersection. Because suppose that in this point f is good is defined. Suppose in this point g is good is defined, but both are defined here in the intersection. And division is picky. Division introduces artificial restriction because you need to include domain of f intersection domain of g, and you exclude minus the part in which x such that g of x is not zero. You exclude, this is minus subtracting what? Subtracting set. And this is the element in which g is 0, you know division by 0 is undefined, so you need to exclude it of the domain. So you compute this part first, and after you introduce the restriction, very, very similar to the thing we are doing in only one function, no? When there is one function. The new thing is two functions. Let's see example, because I need to understand much better this. Suppose case given two functions. Example. Suppose the function f of x is equal 1 over x plus 3, semicolon, and g of x is x over x plus 3. I want to find new function using the combination of f and g. Suppose f plus g of x. But I need two answers. I need the expression. I need domain. Okay? Always. This find the combination of the function and state is domain. Okay? Bueno, the addition is super easy. It's just elementary algebra. You put together f plus g of x is 1 over x plus 3 plus x over x plus 2. However, leave it like that, you can. Actually, you can. But more elegant is when you have fraction, condensing this fraction in one common denominator. And obviously, the common denominator is both factors together. So when you divide LCD, this is my LCD, divided by denominator 1, LCD, denominator 1, denominator 2, numerator 1, and the first fraction, numerator 2, and the second fraction. When you divide LCD divided by denominator 1, it's obvious that that part cancel. And stay alive, x plus 2 times 1 is x plus 2. I finish? No, I continue. LCD divided by denominator 2, now it's cancelled, x plus 2, stay alive. X plus 3 times x is x times x plus 2. Do you follow me? Do you follow me? Yeah, it's easy. Now, leave it like that. No. Let me try to eliminate parentheses and combine like that if it's possible. So it's x plus 2 plus x squared plus 3x. Oh yeah, we can combine like term and organize in descending order of the degree to see elegant answer. X squared, degree power 2 is the first. and 1x and 3x together is 4 plus 2 divided by x plus 3, x plus 2. You can leave it like that, or if you want, you foil that part and that's it. But it's okay. It's a super way. And I finish, no, I don't. Because I need to stay its domain and at the domain of this. So domain of the new function, que es f plus g, is domain of f intersection domain of g. So I separately I investigate domain of f and domain of g. Remember the restrictions 1, 2, 3. Restriction 1 is p divided by q, fraction, semicolon, q not 0. I don't care what happened with the p. P is not important, q is important. Radical e, semicolon, e non-negative. But we have no radical in this problem, only fraction. To say now p divided by radical e, semicolon, e is positive. It's obvious that the restriction can apply in this example is this. You take one by one the expression in the bottom is x plus 3, and this expression no 0. Likewise here, x plus 2 and the expression no 0. So now if you isolate the x to see more clear, it's obvious that this is equivalent to say x no negative 3. And here is x no negative 2. And this is the bad guy. And this is the bad guy in this game. How you represent that? Well. Okay. Let me try to do my best. Okay. Actually, you need to understand that in negative 3 and negative 2, we have a whole, yes or no? A whole. So actually is, let me try to do 3 number line. When you are training, you don't need to take 3, only 1. But it's okay so far. Okay. One more number line. Okay. The first number line is x not 3. X not 3, remember this is infinity positive, infinity negative, infinity negative, infinity positive. This is x no 2, and this is x no 3 and x no 2. Okay, the intersection. Intersection always is and. So that symbol is equivalent to say this is symbol is using in the set theory notation, but this is the logical. Okay, that symbol, this is 0, 0, and 0. And this is only in 3, 1, 2, 3. I know very well. Okay, in 3 we have a whole. And the rest is okay, no problema. The only bad guy in this restriction is 3. And the second one is similar, is 2. In 2 we have a whole, and the rest is okay. Okay, cool. This continues forever, no? However, in the intersection is the common element. However, is no 3 and no 2. No 3 and no 2. Let me use another color, maybe gray color. Represent one hole here in 2, another hole here in 3, and highlight the rest of the value here, here, and here. Now basically, our domain consists in 3 intervals. The first part is from negative infinity, comma to parentheses, parenthesis, 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 because we not include 2 and 3. In this case, union, because it's 3 pieces separately, 2 and 3, union, 3 and infinity. And this is the final answer. This is this answer. The shortcut to do fast is, you understand very well that we have 2 holes. You put 2 holes and the rest is okay. Okay?
Yes, yes.
Let's do a subtraction. Subtraction is the same. The only thing that change is the expression get minus. And the expression is a little bit different, but it's no big deal. Let's see, well, let's do everything. We have time. Suppose f minus g of x is 1 over x plus 3 minus x over x plus 2. Same idea. LCD x plus 3, x plus 2. Divide this by this is x plus 2. But now it's minus, no plus. So we have x times x plus 2. It's similar. The only difference is here was plus. Now it's minus. So it's distributed is x plus 2 minus x squared minus 3x divided by x plus 3 x plus 2. Okay, now you organize in descending order of the degree minus x squared, and positive 1 and negative 3 is negative 2x plus 2 divided by x plus 2. This is the expression that represents the combination of these functions that are now subtracted. And by the way, guys, the domain is the same, because it's the same analysis. The bad guy in the denominator is negative 3 and negative 2. We have to hold in the story. Now let's do multiplication. Multiplication is also easy. It's f times g of x. Is now 1 over x plus 3 times x plus 2 and x together. Multiplication. Multiplication is the easier operation in the fraction. You don't need to find LCD. No, no, no. You multiply top, top, bottom, bottom, and in the story x over x plus 3 and x plus 2. Right? Now, domain is the same. By the same reason. Division, no. Division always is picky, and you need to be aware to face division. Because division included, basically you divide f, gets 1 over x plus 3, divided by x over x plus 2. And division, remember, you copy the first fraction. Multiplication, you change this division problem to multiplication and you flip it that, x plus 2 over x. And now multiplication is x plus 2 times divided by x plus 2. Okay. And the domain, be careful, this is confusing. Now you have extra restriction, extra problem, que es 0. So actually, you need to take care with the original. So basically, what is the domain of division? The domain of division is domain of f division by g is equal domain of f intersection domain of g. It's important consideration g. Why? Because you divide by negative 2 here. Negative 2 plus 2 is 0, division by 0, illegal, right? Now, the extra is when the G is 0. They are coincident, perfect, this and this. However, you need to consider intersection X no 0. So basically, it's the same domain, but you incorporate new restriction, let's say. So basically, we have 1, 2, 3, and 4 interval. And the interval is, let me try to do my best, is from negative infinity to 0, non-included 0, illegal 0, union, sorry, this is intersection, but this is intersection, and, but this is intersection, union, sorry, it's OR. And it's OR because it's 3 pieces you put together in one answer, no? Another is 0,2, another is 2,3, another is 3,3. Okay? Any question? Let's clear the combination for the function using arithmetic operation. It's clear or confused? This part is easy. This part everyone understands very well. Now the part that the students don't understand very well is a composition, function composition. Sure. Function composition. Let me explain in detail. Function composition is represent in that way. Suppose you have two functions, f of x and g of x. You need to find the composition. The composition is the symbolic way, the symbolic way to represent composition is f1, 0. Okay, this is symbolic way to indicate composition. This 0. Okay, don't confuse the student que don't know anything, you know, believe que es multiplication. Composition G. No, it's not multiplication, it's composition. It's a period, and this is a 0, but a small 0. And what means that? Well, that means is G, que is the first function. So you have f bracket G of x. What is the interpretation of this? The interpretation is one, you know, fantastic way to interpret this is you have two functions and you put together, but in this way, like a change of functions. And this is my x domain, get inside in the first function. And obviously, when you plug in one value here, the first function that you evaluate is in G. So this block is G. And this give me an answer, I don't know, okay, it's G of x. And now this G of x is the value, and this value plugging in f in the second function. Okay, the y value in the first function now represent the x value of the second function. In the output, you have f composition G. I promise you see example now to understand more clear. And this is super important. If you change the order of a composition, for example, you change the order like that, G composition F. And you declare que F is the first and G is the second. In general, this is not the same. It's completely different. It's no commutative. You cannot interchange. In some particular example that we study next chapter, you see that yes, it's equal, but it's particular. In general, no. However, F times G, 100% is equivalent G times F. Multiplication, yes, it's nice. Composition, no. And this is super important, guys. Composition and calculus. Remember, you take the subject to be ready to take at least calculus 1 next semester. Well, you need to take trigonometry also. Okay, and be ready to take calculus. Let's see example to understand. First of all, I want to do example using algebraic expressions. It's really easy. And secondly, I want to do a example using the arrow diagram. Gets a little bit more complicated. But don't worry, be happy. Look, example 1 of the composition. Suppose you have two functions. F of x is equal x squared plus x plus 1 semicolon g of x is equal to x plus 3. I forgot to say something important. And something important is domain of the composition. The domain of the composition is equal to the domain of G, and this is important piece because G is the first function you suppose. Because if you do not satisfy G, there's no intersection domain of the new expression. New expression that you obtain when you form algebraically the composition. That includes the second piece. That piece. But this is the most important. That is the reason I put here. And the other together composition, you obtain the second domain, and intersecting both is the domain of the composition. Okay, no problem. I put elementary example, no complication domain, because this is a polynomial function. Poly, and it's a linear function. Okay, linear function is a polynomial degree 1. So both functions are completed, no restriction, no division, no radical. Domain is a real number, domain of this. I suppose that the domain of the composition is a real number again. It's a nice function, no restrictions. Now, the important thing I want to illustrate is find the expression that represents F composition G. And why no? Let me try G composition F. And we focus on the algebra part. Because domain of F, no problema, it's a real number. And domain of G, no problema, it's a real number. And we have no division, we have composition. So I suppose that the domain of the composition again is all real. So now, what is the expression? Well, the expression is, remember, in this order, G is the first function. You need to understand very well, guys. This is my first function. This is my first block. Therefore, this first get inside the second. The second. What you do in algebraically? You take this expression and replace here and here. Okay, and you obtain anyone case F composition G of X, of course, is equal to 2x plus 3 squared plus 2x plus 3 plus 1. The only thing I did was replace 2x plus 3 G inside F. So F is the outermost function and automatically swallow what? G inside. Do you see that?
Yes.
Now leave it like that. No. Remember, final answer, no parentheses. Final answer, combine like term. You apply FOIL here. 2x plus 3 times Z. You FOIL the 4x squared plus 6x plus 6x plus 9 plus 2x plus 3 plus 1. Ready to combine like term and organize in descending order of the degree. 12, 14. Plus 9 and 4, 13. And this is expression that represents F composition. And that in this order. And by the way, remember the formula for the domain of composition. The formula is the composition domain is domain of G, pero domain of G is a real number, and domain of the new expression. Who is the new expression? This is the new expression. And the new expression is also polynomial. And polynomial, of course, not contain division, not contain square root. Therefore, again, is a real number. And the intersection of real number and no real number is obvious all real number. And the domain of the composition is obvious, it's all real. Cool?
Yes, yes.
But let's do it in different order because I want to illustrate one new thing. Suppose I want in the test G composition F. In this case, I suppose, okay, F is the first function, and you take F, here in blue color, and substitution for the X in the second operation. Completely opposite idea. Entonces es 2 paréntesis x squared plus x plus 1 plus 3. Do you see the action?
Yes, yes.
Ah, but this is easy. 2x squared plus 2x plus 2 plus 3. 2x squared plus 2x plus 5. Boom. And this is G composition F. By the way, guys, again, the domain is all real number because both function F and G, the original, are polynomial, and the new expression is also polynomial. And the domain of G composition F again is all real. Cool?
Yes, yes. Yes.
Okay. So I want to do another more complicated example. No, it's more exciting, more complications. But don't worry, it's easy. It's easy. Okay. Do you see this is already recording? No interruption?
It's still recording. It's still recording.
Okay, super. Okay, suppose me this example. Example 2 of the composition is the complicated part. Because the arithmetic, addition, subtraction, multiplication, and division is super easy. Suppose that we have f function. Okay, 4 over x minus 1. And the g function is x over x plus 3. Well, little by little, we, for example, try to find what is the goal. Find f composition g expression and also state is domain. Okay, no problem. I can see clear like water that my innermost function is G. Therefore, that G I substitute here. Now the expression at least is F composition G expression is 4 over x plus 3 minus 1. Do you see that?
Yes, yes.
Now I try to put an elegant way to find the least common denominator. Obviously, this is 1, this is a whole number. And I suppose the denominator is 1 over 1, so x plus 3 is my least common denominator. We have x here, minus parentheses x plus 3. Makes sense in this transformation, right? Because once you spread x over x plus 3 and minus x plus 3 divided by itself is negative. Now, I distribute x minus 3 divided by x plus 3. I remove the parentheses, apply distributive. Wow, I can see how this is cancelled out. Say goodbye. So we have 4 over minus 3 over x plus 3. And now, I don't like this answer. I divide this. 4 over 1, okay, the numerator, multiplication by flip that, x plus 3 over minus 3. Okay, cool. So now, let me try to do something extra, and that's the multiplication, top, top, bottom, bottom. So it is 4 parentheses x plus 3 divided by negative 3. Or more elegant, in my opinion, is negative 4/3 parentheses x plus 3. And leave it like that. We can manipulate if you want, remove the parentheses, distribute again, it doesn't matter. Well, let's do it. Why not? Is suppose que another two say, no, I don't like this. Okay. So you multiply a negative 4 over 3x minus the 3x cancelled minus 4. It's another possibility. So press the same idea. Okay, this is a new expression that they want in the problem. New expression. Form the combination f and g in this order. G first, f second. And what about domain? Well, the formula for the domain is, look, domain of the composition, the domain of f composition G is equal to domain of G, because G is the most important, intersection domain of the new expression. But the new expression is this, or this. Okay, I can see it's linear function. Right? It looks like y equal mx plus b. M is negative 4/3 and b is negative 4. It's linear. This is a linear domain is over a number. No restriction for this part. The only restriction that we have is the domain of G. And the domain of G, you take the expression and the denominator is x plus 3, and you need to avoid to be 0. Therefore, x not 3, no negative 3. Sorry. And this is my domain. So basically, so you write always in interval notation, the domain is infinity, negative infinity, 0, negative 3, negative 1, negative 2, negative 3. And negative 3, I know that we have a whole. And this no, it's non-defined. This is linear. And the rest is all real number except negative 3 is the bad guy. The rest is the good guy. Continue forever, continue forever. So the domain is another way to express the same idea is from negative infinity, comma, negative 3, union, negative 3, comma, infinity. Cool?
Yes.
Let's do it now in different order because I want to discuss everything. Suppose inside the example 2, I want to investigate, but you find out G composition F of X. Again, expression, boom, boom, and states domain, boom, boom. And the answer for the first part A, and this is part B. Part A, the final answer is this and this. Let's do in part B. I interchange. I need to be aware that we expect a completely different answer because the composition is not commutative. When you interchange, it's completely different idea. Let me try. I write again f of x. Okay, is 4 over x minus 1, semicolon. D of x is x over x plus 3. But the situation now is different. we have the function f, que es the innermost, and the function s, plugging in, replace x and g for this and this. Basically is g composition f is 4 over x minus 1 divided by 4 over x minus 1 plus 3. Do you follow me? Do you understand what you're doing?
Yes. Yes.
Now I try to eliminate the fraction. Therefore, I am doing first this and this together. So the LCD is x minus 1. We have 4 plus 3 times x minus 1. Something like that. Okay, now distribute it. 4 plus 3x minus 3 divided by x minus 1. Okay, so now we have a fraction. Well, no, actually 4 over x minus 1 divided by 3x plus 1 equals 4 minus 3 is 1 divided by x minus 1. Okay, now we have division. And division, you copy numerator, exactly the same. I don't touch, I just bring down. And multiplication by the reciprocal of this. And it's cast 4 over 3x plus 1. That is my new expression. But in this case, domain is no all real number like this. In this case, the domain of new expression is, okay, apply the rule. You take denominator q, que es 3x plus 1, and no 0, and solve this inequality. 3x no equal negative 1 divided by 3. Entonces you see que x no negative 1/3. This is the domain. The domain is all real number, but you have a hole in negative 1/3. Okay, so we come back again to the famous formula. That famous formula, I want to copy one more time. Domain of G composition f in this order is domain of f, que es the first function. This is most important. Intersection, domain of the new expression. Domain of f, look, this is f. It's obvious. Can you take the expression in the denominator is x minus 1, no 0. Therefore, it's no 1. 1 is the bad guy. So the domain of this is all real number except 1. And this is all real number except negative 1/3. So what is the domain of f? It's all real number except negative 1/3 and positive 1. So you are doing the numeric, I highly recommend doing the number. Okay, I highly recommend doing the number because you know it's very important. It's the image, and the image illustrates very well the situation where you have compound inequality. No, this is minus infinity. This is positive infinity. 0 in the middle. We have 1 here. And negative 1/3, using my imagination, is it's a negative 1 and negative 1/3 here. Negative 1/3. And negative 1/3, we have a hole. And in 1, we have another hole. The domain is from negative infinity to negative 1/3, and between negative 1/3 and 1, and after the 1 to infinity. Okay, how do you write that? Domain of G composition f is equal, in this particular example, from negative infinity, comma, negative 1/3, parenthesis, no including negative 1/3, union, negative 1/3, comma 1, union, 1, comma 4. Boom. Finals. This is easy or not?
Yes, yes.
Let's do one more. One more similar, no? And this one more bring me new surprise. New surprise. Que sometimes happen. Not always happen, but sometimes happen. Example 3 of decomposition. Supposed to function f. Okay, it's 4 over x minus 1. Oh, similar to the previous. However, G no, G is different. Is 4 plus x divided by x. Same thing, guys. Find the expression that represents the composition in this order and state its domain. And find the expression that represents in opposite order, G is F first, G secondly, and state its domain. Cool. But I realize that G is the innermost function. Therefore, that function, go here. Now the expression for the composition is this, is equal 4 over 4 plus x over x minus 1. Do you see that? Okay, what should I do? Well, LCD is x. Is 4 plus x minus x, because this x times 1 is minus x. Wow, something weird happened here. This x is cancelled out, and we have 4 divided by 4 over x. Again, we have fraction. Actually, this is whole number 4. This is 4 over 1. Time, flip it, x over 4. And the 4 is cancelled. Wow. And you get x. And x, remember, in the table I provide you, is identity function. Identity function. Why is identity function? Because any function that's equal x represents the function y equal x represents a line passing through the origin at 45 degrees. So now, so you take 1, the answer, and the y is 1. So you take 2, the answer is 2. So you take negative 1, the answer is negative 1. It's identity. So the y value is equal to the x value. And when this situation happens, when you put together in the composition way, and you get identity function, that means that function f and g are inverse function, because when you put together in this way composition, like undos each other and give me identity. And you can see in the next chapter what is the importance of this idea. Okay, it's inversion, but you don't know very well what means inversion. Now, what is the domain of this? What is the domain of f composition G? Well, according to the formula, remember, is domain of G intersection domain new expression. But new expression is identity. Identity is a real number because it's a line. So no problem with that part. That part is irrelevant. The important part is this. And domain of G is no 0. X no 0. Okay, there's a domain of the composition is, again, I put my all real number line to visualize much better. The student that don't need that, no problem, I understand. But I need to explain this. Infinity positive, infinity negative, And the only guy we have problem is n0, undefined, to be undefined. So we have a hole here, n0, and the rest is okay. And the rest is okay. So domain is then domain of F composition G, capital D, is from negative infinity 0, no including 0, union 0. So the only bad guy is 0. Cool?
Yes. Yes.
And the new thing I bring with this example is when you put together in that way composition, this function is because this function is inverse of this function, or f is the inverse of this. And what is that? Maybe you remember, maybe you don't remember, but it's not my goal to explain now. Inverse. Now, by curiosity, let's do it backward. Find decomposition f. Oh, I switched the order. I know very well that no, it's different. It's different. I copy again now. F of x is equal to 4 over x minus 1. Semicolon, g is 4 plus x divided by x. Okay, in this order now, that expression is f go inside the x here and here. Okay, good. Is 4 plus, this 4 is this. This x now is 4 over x minus 1. This x is exactly 4 over x minus 1. It's my new complex fraction. No problema. Define the LCD. It's x minus 1. Because you have 4 times x minus 1 plus 4. Divided by 4 over x minus 1. Okay, don't touch for a moment. No? Okay, you distribute it. And when you distribute it, at the top, we have x minus 1, 4x minus 4 plus 4. 4 over x minus 1. And it's 4, it's obvious we cancel out this. And we have 4x divided by x minus 1 divided by 4 over x minus 1. It's a 4 guy, no y. Okay, now finally, I divide 4x over x minus 1 times, flip it out, x minus 1 over 4. Wow, x minus 1 is cancelled, 4 is cancelled, and it stays again x. Wow, it's no coincidence, it's a fact. When the functions are inverse each other, the composition in either order is the same, it's identical. This situation not frequently happen, only happen when the function f and the function g are inverse each other in either order. And what about domain? What is the domain of g composition f? According to the formula is domain of f, is the most important because it's the first intersection, domain of new expression. New expression again happen is all real number. The same. This part is totally irrelevant. And we focus in the domain of f is x minus 1 no 0. It's equivalent to say x no 1. And that's it. The bad guy in this example is 1. The rule again, the bad guy is 1. Okay, all real number. 0 in the middle, the bad guy is 1. And 1, I know very, very well that we have a hole. And the rest is okay. Therefore, domain of G composition F is from negative infinity, comma 1, union 1, comma infinity. Boom. Final answer. This is domain of this and this order. And this order not necessarily the same. Do you understand this idea or no? Okay. But I know I need to explain more in the composition. Because composition is a little bit weird, no? But it's important. Super important in calculus. Okay, you see combination of the function, one function inside another function is a composition. So I bring one example to illustrate much better, well, much better, no, another point of view of the composition. Using arrow diagram. Suppose that we have a function g. And the representation for the function g using arrow diagram look like that. We have different points. We have 1, we have 2 different values that represent domain. This is domain of G, and this is the range of G. 1, 2, 3, 5, and 6. Associate somehow with the 1, 2, 3, and 9. And this order, guys, 1 is 1, 2 is 1, no problema, no? Because there's many to 1. And remember, the important thing to be function is that we have 1 in the range, no? Many to 1 is okay. 3 is 2. 5 is 9. And 6 is 3. Wow. Okay. This is the situation of the function h. The situation of the function f. Again, similar. No? We have the domain and range. This is domain of f. And this is the range of f. And domain is 2, 3, 4. Guys, this is important. This is not too much, but there are problems in Alex like that. In my test, no. But in Alex, yes. 8 and 9. And here connecting by 2, 3, and 6. 2 connecting by 2. 3 connecting by 2 also. 4 is connecting by 6. 7 is connecting by 6 again. 8 is connecting by 3. And 9 is connecting by 2. Wow. Okay. Here I need to investigate F composition G of X. Okay, of course no expression because it's arrow diagram, but I need to investigate domain. Okay, so now remember the composition, the interpretation of the composition is two functions connecting by a change of function. The first block is G. It's obvious, right? So this value X plugging in here, input X equals something. This is my input. Evaluate first in G, and after, remember the another notation is F bracket G parenthesis X. You plug in any value here. After you see value, I promise. And the output of this block go inside the second function as f. So basically, I need to state the change, this change in between this function and this function. Therefore, to guarantee the continuity of this function, I need to investigate what happened in between range of G intersection domain of F. So the continuation here, what is the continuation here in that part? What is the common element you can see? Well, you can see 2 is common, look. 3, yes. And 9, yes. But 1, no. And 4, 7, and 8, no. But the only guy can guarantee the continuity. So basically, see, I following, look, to state the change in the composition, you have, this is the first set. Okay, this is this. I bring down, but I bring down especial. I excluye 1 and 2, no. Why no? Because that's associated with the 1, and 1 do not guarantee the continuation here. So basically, this I copy not completely the domain of G. See, I copy a subset of 3, 5, and 6. Okay. Now in the middle, I copy which one? This or this? No, I copy this. Okay, it's the intersection. Okay, it's the only guy guarantee the continuity. Okay, it's 2, 3, and 9, right? And what's the connection? What is the connection? 3 connected with the 2. Look at that. 3 connected with the 2, and 2 connected with the 2, and guarantee continuity. And 5 continue with the 3. No, to the 9, sorry. To the 9. Look at that. 5 to the 9, and 9 continue here. 9 continue here. And 6 with the 3. Let me see. Oh, yeah. And 3 continue here. 6 to the 3. Okay, this is one subset. Say this is the, what is the name of this guy? Well, the name of this guy is, I don't know. This is the range of G intersection domain of F. And finally, why not? I bring down this guy. Oh, but I bring down, look. I suppose que I delete mentally, I delete this 3 and this 6. Why? Why not? Because to guarantee the continuation, look, 2 is associated with the 2, 3 is associated with the 2, and 9 is associated with it. And the other guy cross here, 4, 7, and 8 is no continuation. Therefore, this is 2, just 2. Therefore, 2 is associated with the 2, 3 is associated with it, and 9 is associated with it. So in this line, I put the simplification of this. So what is the conclusion, Professor? Well, I don't care that part. That part is not important. This is the intermediate stage. Okay, suppose it's this. I don't care. But the important thing I care is the domain and the range. 3, 5, 6, and 2. And 3 automatic is associated with the 2. Look at this path. 5 is associated 3 and 2. Again, that path. And 6 is associated with the 3. No, this is 9. Intermediate value. This is 5 is associated with the 9, associated with the 2. And 6 is associated with the 3, and 2 associated with the 2. The super fantastic conclusion is que the domain of F composition G is this guy. Is x such that 3, 5, 6. So that's it. This is the, and this is the range. And the range is just the y value such that y is equal to, or just 2. Not necessarily put y equal, no? It's y2. Here, 2. It's relatively easy to understand this, right? However, I want to not complicate, include one extra idea. Suppose I want to evaluate F composition suppose I want to evaluate F composition G, evaluate and different value of this 1, 2, 3, 5, 6. Evaluating 1, F composition G evaluating 2, F composition G evaluating 3, F composition G evaluating 5, and F composition G evaluating 6. So basically, I take the original element in the domain of G. Because I suppose it's the good candidate to be domain of the our composition function. Okay. N1 es obvio que es undefined. Because you evaluate N1, you moving for this path, and you don't go to the end of the change. You lost here. Stop. That is a reason, and this is obvious. Okay, 1 don't belong to the domain. You see 1 here? No. You see 3, 5, and 6 only. Okay. Likewise, N2 is undefined. However, in 3, 5, and 6, so you following the path, or you see more clear here, get the only value that you have in this domain. 2, 2, 2. End the story. Do you understand this or no? Clear or no? Come on, answer me. Are you here or no? You are sleeping? Guys? Answer me. You understand this? Yes. Edward.
Yes.
Yes.
Okay, entonces you are ready to start review. Slow down, little by little. When you finish and you have no problem, you have no question, you are ready to take the test number 1. You continue working in the test and the homeworks, plural, and the test number 1 online. Monday? Yeah. I will send I'm doing my best for the student, no? You are good students. Okay. I feel you are. Let's move on to the review. Let me see if it's possible to complete the homework in Alex. Give it extra. Yeah. So suppose you complete the homework in Alex, but you need to get a score greater than 80. So you have 80, 80, 80 in 3 homework. No, it's 3 homework, right? Or 85, or 82, or 90 something. 3, yes, 3. Obviously, you get 100 in the test. I will put 110, and it's community throughout the semester. Entonces son students in the last test, number 5, maybe get no super fantastic grade. However, you get easily the 8 in the class. Okay. Let me try, guys. Let me try to come back to the whiteboard. I suppose you see, no? Whiteboard. I don't know if I can see or not the review. I make a screenshot, at least the first part. Document. Let me try. No. That one. Down. Suppose the first page. There you go. Cool. Cool. This is 3 pages, the review. Okay, don't worry, be happy. Everything is easy. Let's do the first question. The first and the second question is compute the square root negative number and multiplication each other. Suppose number one. Square root negative 16 times square root negative 25. Remember, you compute separately. If you put together, become positive, is wrong answer. This is 4i, and this is 5i. And this is 20i squared. Yeah, I know very, very well. K squared is -1, and the answer then is -20. It's okay? Do you follow me? Do you follow me?
Yes, yes.
Yes.
One question in the test, you see. Number one. Number two. Square root negative 81 times square root negative 9. This is 9i, and this is 3i. It's 27i squared. Yeah, I know que I squared is -1. I squared is a real number. It's -27. Okay? So you leave it like that. It's not wrong, but it's incomplete answer, right? You need to know, it's important that you need to know que I squared is real, no imaginary anymore. No. So far, no problem.
So far, so good.
Excellent. Now, number 3 is super easy question. Super easy question. However, some students make a mistake because some students don't realize that this is addition and subtraction, and some students apply FOIL. FOIL is only multiplication. FOIL is multiplication, no addition, no subtraction. So we have 3 complex numbers. 5 plus 8i, one complex number, minus subtracting another complex number, plus another complex number. So the only thing that you should do is remove the parentheses. 5 plus 8i, minus 1 minus 8i, plus 2, plus 10. And we combine real. 5 minus 1 is 4, positive, plus 2 is 6. Imaginary. Well, this imaginary is cancelled out because positive a and negative a, and the answer is 10. Oh. Final answer. That's it. Guys, no FOIL. FOIL is multiplication. Some people, 5 times 1 is 5. 5, 40, no, what the hell? Number 3, do you follow me?
Yes.
Yes.
Number 4, yes, it is multiplication now. And you FOIL. 3 times 2, 6. 3 times 5, 15. Minus ai minus 20i squared. Remember the shortcut I explained your moment. I never write in my paper. It's up to you. So you write I squared ai chain to positive. I like that way. Another student said, no, I don't like this. I like in the tradition step by step. Okay, I respect. It's 20i squared. So negative times positive and negative. And I times I squared. You say you are doing down one extra step, in which you replace by positive 20, because I know I squared is -1, and negative double is positive. So you combine real 26 plus 7, 15 minus 8 is 7. Okay, boom, that's it. Easy or not?
Easy.
I know. Okay, so now let's Move on equations. Quadratic equation, quadratic equation, quadratic equation, quadratic in front equation, radical equation, absolute value equation, and inequality. Okay. 5. Question 5. Question 5 is x plus 8 squared equals 17. Okay. This equation is quadratic equation. You don't need, so the easy way to solve that is not necessarily expand this x plus 8 times 7. You can, but it's too long process. However, I take advantage that somebody do the factorization, that part, and you apply that directly square root of 7. This is square root method, is the easy way to compute the solution of the quadratic. And you know very well that square power and square root cancel out each other. And don't forget, you put plus or minus, and square root 17 is leave it like that, because 17 is prime and number, we can know simplification more. And finally, so for x, like a linear equation, you move 8 to the other side subtracting. Okay, leave it like that, super perfect. Or the student can need to separate the solution. Solution set is minus 8 plus radical 17, comma, minus 8 minus radical 17. This is not strictly necessary. When it's a complex, yes. When you have I, yes, you separate. If you want, no? But always is possible to express it using this symbol plus or minus. But in this case, no complex, it's real. Of course, it's real weird, it's real irrational, because somehow involve square root of the prime number, case irrational number. Cool?
Yes. Yes.
Let's move on to number 6. Number 6 is classical quadratic equation, and they want to use solving using quadratic formula. Okay, I love the quadratic formula. I hate the completed square. However, in number 7, you see it's mandatory doing by completed square. That's meaning in the test, one question, you need to solve it by completed square. You don't solve it by completed square, no credit. Okay? Okay, so now it's ready, express it in standard. Therefore, it's easy for me to determine who is A, B, and C. A1, B1, and C2. I'm plugging it into the quadratic formula. Okay, -1 plus or minus square root 1 squared minus 4 multiplication by 1 multiplication by 3 C divided by 2 times. Remember, always order of operations. This operation inside the radical. That's the first thing you should do. 1 squared 1 minus 12, 11, negative 11. And square root negative 11. What is the reason I compute the square root? Because the formula have a square root. So you compute the expression inside the square root, and after you apply the square root. And this is imaginary because I know very well the square root of negative number is I square root 11. So now so far we have -1 plus or minus I radical 11 divided by 2. And I split this. This is the typical format of the complex number, no? You have real part. This is the real part, and this is the imaginary part. Okay, so you write that way, separately, real part and imaginary. Therefore, you split this common denominator. Equation number 6. No? Okay, so I propose you, because I know it's too long, doing one more, and that's it. Okay? We continue Monday. Number 7. Oh, number 7 is confusing because it's by completed square. I don't like this, but I need to learn this completed square. Okay, so is, let me copy. This is the last one for today. Too much. Is x squared plus 4x plus 29 equals 0. It's a quadratic equation already expressed in standard, but they want to use completed square. I bring down x squared, I bring down 4x. They investigate what is the number que complete the square. Okay, que es b over 2 square. B is 4 in our problem. 4 divided by 2 is 2, square 4. It's a coincidence. If this number is not 29, it's 4, I finish, it's super easy. But unfortunately, no, it's 29. So what is the organization? Well, the organization. There are many ways to do this. But you move 29 to the other side. Okay, minus 29. And when you include 4, because we need to complete the square, you put extra 4 here. This is one way to organize this. Therefore, this trinomial is perfect square. And the factorization actually is only one parenthesis, not the classical 2 parentheses in any trinomial. No, because they are twin brother. X, 2, 2, because 2 times 2 is 4, and 2 plus 2 is 4, and plus. They actually, no, write like that. No, please. You write like that, it's better. And this is minus 24, right? Minus 29 plus 4 is minus 24. Now square root both sides. X plus 2 is equal plus or minus. Don't forget plus or minus 5. Therefore, x is equal to minus 2 plus or minus 5. Final answer. In this case, complex solution, and the complex solution always coming by pair of conjugate, plus or minus. Actually, it's minus 2 plus 5, and minus 2 minus 5. Conjugate. Guys, enough. Okay? Okay, we continue Monday. Okay, cool. Fantastic. We are the best. We continue Monday, and I will send soon the test. Suppose que I send today in the video, in the email video, I send the test on paper, and you start working this. Okay? And remember, the due date is September 14. You have time to do fantastic, right? Do you understand?
Yes.
Bye bye, guys. Take care.
Bye, Professor.